Hello, teacher. Welcome to my presentation. Now I'm going to talk about my final exam, and it's the project. It's the project named the Animal Sound Recognition based on the machine learning algorithms. Then I introduce and the motivation of the project. The sound of the recognition system The sound recognition systems of animals is have involved in the system to survive in their environment. The the animal sounds can be helpful for human beings in terms of security prediction of natural disaster, and intimate the interactions if we are able to recognize them properly. The recognitions of animal sounds helps us to identify what species are the living in the certain area, in addition to classifying the individuals within each species. In the picture, we have two Wi-Fi is cats and dog. The audio is represent the time series waveform, like in the picture, and we have two sounds of cats and dog. We put in the model training, and it can predict the output is a cat, maybe cat, or maybe dog, something like that. And I will talk about the data set that I use in the project. I use a small data set that was developed from the keyword named our cat and dog. The datasets have two classes named cat and dog respectively. It has it has 164 word files, and dog has 113 word files. And in the picture, the numbers of labels of each cat and dog cell is quite quite imbalanced. It's maybe at the it's maybe interval maybe it's not good for us model training. So I also split the data set into two small sets training and testing. So the 15 the 59.2% of cash labor, and for uh, 40 40 40 of 40.8% dog labor. And we before we training before training I have to pre-process my data. So I process the data, the cat cell and dog cell, with the same series waveform. It's so amplitude information from the receiving microphone. You can see the the plot, the waveform of the cat cell, and it's different than the waveform of the dog cell. It's also in the spectrogram of cats and dogs respectively. There are one domain in the cat cell, but in the dog cell have two. And you see that in the real life cats, dog when they barking, they always have two sound. From the spectrogram, we see how frequency content train with the time. This align with the reality, and as a cat smell cell is high pitch and layered with the harmonics. The dwarf appear to produce a sudden and strong bass tone with the frequency content spread through the spectrum. After we plot the data and we have to uh, extract feature uh, in data, and in this my project I use MFCC. It stands for the melt frequency spectrum coefficients in the audio. Uh, in the audio recognition problem input with the audio signal, we have to predict the text from the audio signal, and we use the MFCC. That is a widely used technique for the extracting the feature from the audio signal. We have a raw data, and the first step we have to convert the analog digital analog signal to digital signal uh, signal, and then we next step we have a print passes, and after the step of print passes we use with slide window in the data signal data sound, and the we get the signal, the data, the feature of the signal, and we put and then we apply DFT. It stands for the degree Fourier transform, and next step we use melt filter bank, and also you can see in the picture, and then the output of multiplying we have apply logs to lower the frequency, the lower signal, and then we apply inverse DFT, and the last one we get the fixture transformed by MFCC. So in my data sets, we use the LibRosa library to read, and using the LibRosa MFCC function to extract feature to extract the waveform, the castle to castle files to of 41 feature x Wi-Fi. And in this the feature extraction topics, I also use the zero crossing rate. Zero crossing rate of the an audio frame is the rest of the side train of the signal during the frame. In other words, it is the numbers of time signal tree chance value from the signal to negative, and vice versa divide the length of the frame. Zero crossing rates can be interpreted as a measure of the noises of a signal. As you can see in my slide, the picture with the original signal, it's very noise. But we apply the zero crossing rate. It seems like very clearly. So the algorithm I use in my project is the support vector merging. It's very useful for the classification problem. So in the algorithm we plot the data item approach in the n-dimensional space, with the values of each feature being the values of the particular coordinates. Basically, we, we have to find the boundaries and find the hyperplane to separate the x class and separate the data points of the x class. And then we have the kernel. It's for kernel. It's lin kernel, original kernel, linear kernel, or polynomial kernel, and Gaussian RBF kernel. Let's link to my experience results. So I have two progress, a training progress and the run real-time progress. The training I do as the same in midterm project. So I load Wi-Fi by using LibProsa library, a feature extraction with MFCC, training with model FEM, and classification and evaluation of the model. But next to the run real-time progress, the first thing I have to do is I check the model again. And I check model again. I use the less deep and let's discuss deeply in next slide. It's a future slide. So let's talk about training progress. We load data from the directory and split data into training set and testing sets with a rest of 1/3, and we also normalize data. We use the library, libstar library to list and to extract feature to what you want feature in each work file. And you can see the training set is have 187, 85 work file, and test sets. Testing sets is have 92 work file. And see, I extract cast sound using MSC. It seems very clearly. And we evaluate the signal at the model. We see that the accuracy of the model is quite good. You know, the ARM score approximately 19%, and the accuracy is also 88%. And we plot the composition matrix of model FEM. You see that the model is classified quite well. The 49/20, the 52 data points of cast is classified correctly, and also the 34/40 data points of dog. Let's link to the real-time training progress. Firstly, I used to test raw datasets from the photo root to check, that is test the raw dataset to check by using while loop. We implement X loop. X while loop. We read one Wi-Fi and we check the accuracy of the testing raw dataset that I prepared. It gave a high good prediction that get 78% accuracy, and because it's quite good. I use in the run real time, and I implement run real time in my laptop by using a phone as audio resource. And our laptop gets audio by voice recording, and we use Voodoo to break sound. Is we to break the sound is gotten is cat smell or dog barking. Let's next to my demo. Okay, let's next to my demo. Where my demo? Okay. As you can see, this is the I use to training progress. That seems like it look like the midterm project, uh, but you can see in the next and see here, I import the pickle library to save model, and then I load model again to evaluate the model with my my root dataset to my test raw dataset. You know, it's never test real time. It's a raw data. So I I label datasets and I use while loop um, to read the files of the groups of the file of the test real time. So it will generate the accuracy. So I evaluate the model in my test of real time is you know 7%, 70%. It's maybe it is not good, but with small data sets, it's maybe in overfitting. But when we use in real time or use in another the data sets we use in your real time, it's predict not good. Uh, okay. Thank you for watching my my presentation. And tomorrow, I want to show you my real time by using my phone, the sound of my phone to classify the dog sound and the cat sound, the animal sound. So thank you so much for watching my presentation. Thank you.